Hello and welcome to another Space Gas tutorial. In today's session, we'll focus on getting you comfortable with creating and editing structural models using the graphical interface. We will create a simple sway frame with a lean-to and a curved rafter that cantilevers out past the right-hand column. First, select the Draw Member tool from the main menu. Then, begin by drawing a vertical column starting at the origin. Set the column height to 8 meters. Next, we'll draw the second column. Hover your mouse over the origin for about 1 second, then drag it horizontally. Type in 10 meters, and the starting point will snap exactly 10 meters from the origin. From that point, draw a vertical column with a height of 4.2 meters. Repeat the same process to draw the third column, this time positioning at 5.5 meters from the central column. Next, we'll draw the rafter. Begin at the top of the left column, then press the @ symbol on your keyboard, usually entered by holding Shift and pressing the number 2 to start entering relative coordinates. Enter at 12.5, 2.5. This tells Space Gas that the other end of the rafter is 12.5 meters in the X direction and 2.5 meters in the Y direction relative to the starting point. Now we're going to convert this rafter into a curved rafter with a 30-meter radius, approximated using 7 straight segments. Next, we'll complete the central column by adding the missing vertical segment. It's fine to make this segment slightly longer than necessary. Once it's in place, connect the rafter to the vertical column. And then delete the redundant portion of the column that extends above the rafter. At this stage, we've completed the 2D geometry of the frame. Next, we'll assign the cross sections for each column. The left and centre columns will use the 530 UB 82.0 section. For the curved rafter, we'll use the 410 UB 53.7 section. For the right-hand rafter, we'll use the 250 UB 25.7 section. And for the right-hand column, we'll assign the 310 UB 32.0 section. Next, we'll assign supports at the base of the columns. For this frame, all column bases will be modelled as pin supports. We'll also add a hinge at the end of the right-hand rafter, where it connects to the central column. In the next stage, we'll assign 3 load cases to the model. The first load case will include the self-weight of the structure along with the superimposed dead load. The superimposed dead load is 0.75 kilonewtons per metre. The self-weight can be calculated automatically by GASS. Keep in mind that all models in GASS are treated as 3D structures. Even though our frame appears to be 2D, GASS will still assume it can deform out of plane. For this exercise, we're assuming no out-of-plane deformation, so we'll apply lateral restraints to all nodes above ground level. Next, we'll assign the live load of 3.2 kilonewtons per metre, applied as a global projected load along the curved rafter. And wind load of 2.85 kilonewtons per metre on the left column. And finally, we will create some critical combination load cases. The model is now fully complete, so we can proceed to run the analysis. You can now review the analysis results, including deflections, bending moment diagrams, and any other result types that are of interest to you. Note that at the hinge location on the right-hand rafter, no bending moment is transferred between the rafter and the column. That's it for today's tutorial. If there's a particular topic you'd like to learn about, feel free to leave a comment below. Thanks for watching.